Phoenix just hit 118 degrees. Not a heat index number, not a feels-like figure. An actual air temperature of 118, the hottest reading the city has recorded in the month of August in its entire history. And one of the hottest days measured anywhere in that city since record-keeping began back in 1895. At the same moment, a wall of dust nearly a mile wide was rolling across the same metro area, strong enough to knock out power to tens of thousands of homes. And a few states away, fire crews were watching humidity readings drop into the single digits under red flag warnings stretching across 5 states. Right now, roughly 60 million people across the United States are living under some form of active heat alert. That's not a scattered, regional problem. That's close to 1 in every 5 Americans, under a warning telling them the air itself has become dangerous. And this isn't a single, isolated event. It's 3 separate hazards stacked directly on top of each other, all connected by the same weather pattern. By the end of this video, you'll understand exactly what's driving all 3 of them, why they're happening together and not by coincidence, and why this kind of stacked extreme weather event is becoming a lot more common than it used to be. Let's start with the number that should stop you cold. On Thursday, Phoenix reached a high temperature of 118 degrees Fahrenheit. That single reading did 2 things at once. First, it became the hottest temperature ever officially recorded in Phoenix during the month of August, beating every previous August day going back to when reliable local record-keeping began in 1895. Second, on a citywide, all-time, any-month basis, it tied for the 9th hottest day ever measured in that location, in a record that now spans well over a century. That's not a city having a hot week. That's a city brushing up against the physical ceiling of what's ever been documented there. And Phoenix isn't alone. Extreme heat warnings, the National Weather Service's most serious heat classification, reserved for conditions considered genuinely life-threatening, are currently active across Palm Springs, California, Phoenix, and Tucson in Arizona, and stretching through Death Valley and the lower Colorado River Valley, where afternoon highs are running between 115 and 118 degrees. That's Death Valley, a location that already holds the record for the hottest air temperature ever reliably measured on the surface of the planet, sitting under a warning that treats even its normal summer extreme as newly dangerous. Outside the immediate desert core, the heat advisory zone spreads even further. Albuquerque, New Mexico, Dallas, El Paso, and Amarillo in Texas, Oklahoma City, Wichita, Kansas, Denver, Sioux City, Iowa. Across that entire stretch, highs are expected to land somewhere between 100 and 110 degrees. Brutal numbers on their own, even if they don't carry the same extreme label as the desert Southwest. What's actually driving all of this is a strong ridge of high pressure parked directly over the desert Southwest. Essentially a massive dome of sinking, compressing air that acts like a lid clamped down over the region. Air, sinking under high pressure, compresses as it descends, and compression heats air up, the same basic physical principle that makes a bicycle pump warm to the touch after you use it. That sinking air also suppresses cloud formation, which means there's very little to block direct sunlight from baking the ground, hour after hour. And crucially, this particular ridge has been essentially stationary, parked in place for days rather than moving through, which means the same patch of desert keeps getting hit with the same intensifying heat, day after day, with almost no relief overnight either. Meteorologists have specifically flagged the lack of overnight cooling as one of the most dangerous features of this event, because without nighttime temperatures dropping enough to let bodies and buildings recover, heat stress compounds day over day rather than resetting. Local forecasters have labeled this a major heat risk event, under the National Weather Service's newer heat classification system, 1 level below the maximum extreme category, but still describing conditions capable of affecting anyone without access to adequate cooling or hydration, not just vulnerable populations. That distinction matters. This isn't a heat wave that primarily threatens the elderly or people with pre-existing conditions while everyone else just feels uncomfortable. This is heat, severe enough to pose a genuine risk to healthy adults who spend meaningful time outdoors. It's worth understanding how that heat risk system actually works, because it represents a genuinely different approach than the older, more familiar heat index. The heat index, the feels-like number most people are used to seeing on a weather app, only accounts for air temperature and humidity. It treats every hot day the same way, regardless of how the human body is actually coping with it. Heat risk instead pulls in a wider set of variables: how unusual the heat is for that specific location and time of year, how long the hot stretch is expected to last, whether nighttime temperatures are dropping enough to offer real recovery and broader public health data on how heat-related illness tends to spike under similar conditions. A major or extreme heat risk rating, in other words, isn't just describing a number on a thermometer. It's describing a health threat calibrated specifically to how dangerous this exact stretch of heat is likely to be for the people actually living through it, which is part of why forecasters have been leaning on it more heavily in recent summers as a communication tool. Here's where this story gets genuinely strange, because at the exact same time Phoenix was setting a heat record, a completely different hazard was rolling through the same metro area. A massive, fast-moving wall of dust, tall enough and wide enough to be visible from miles away, that plunged parts of the city into a haze thick enough to cut visibility to almost nothing. This is what meteorologists call a haboob, and if you've never seen one, the physics behind it explain why it looks so much like something out of a disaster movie. A monsoon thunderstorm builds up over the desert, and eventually it collapses. The rain-cooled air inside the storm becomes heavier than the surrounding warm air and comes crashing straight down toward the ground at speeds that can approach 100 miles per hour. When that column of falling air slams into the desert floor, it has nowhere to go but outward. Spreading in every direction is what meteorologists call an outflow boundary. Over Arizona's loose, dry desert soil, that outward rushing wind doesn't just blow. It scoops up an enormous volume of dust and sand off the ground and lofts it into a churning wall that can climb anywhere from 1,500 to 5,000 feet into the sky and stretch dozens, sometimes over 100 miles across the landscape. The storm that generated the outflow may already be miles away by the time the wall of dust itself arrives, moving as its own independent weather event. This particular event pushed into the Phoenix area as a surge of moisture out of the Gulf of California moved into southwest and central Arizona, driving a statewide uptick in monsoon thunderstorm activity. The National Weather Service issued blowing dust advisories covering the Buckeye and Avondale areas, South Mountain and Ahwatukee, and the southeast valley around Queen Creek. The storm's winds knocked out power across the region. Utility company SRP reported roughly 17,000 customers without electricity in Maricopa County alone, with over 1,000 more affected in Pinal County, while a separate utility, APS, logged nearly 3,000 additional outages in Maricopa County on top of that. What makes this month particularly notable is that this isn't even the first major dust event to hit Phoenix recently. Just weeks earlier, the city was struck by 2 separate dust storms strong enough to register as Category 5 events on a relatively new, scientifically vetted dust storm intensity scale. A rating built specifically to categorize these events based on real-time particulate concentration data collected across a network of more than 20 sensors positioned throughout the Phoenix metro area. The scale doesn't just assign a single number based on wind speed, the way something like the Saffir-Simpson hurricane scale does. It factors in 3 separate dimensions of a dust event: how long it lasts, how widespread the dust plume actually is across the metro area, and the wind speeds driving it, before combining all of that into a single category rating. Meteorologists who study this scale have noted that back-to-back Category 5 dust events within the same short window is. There's also a counterintuitive detail about dust storm severity worth understanding. A dry monsoon season doesn't necessarily mean a quiet one for dust. When thunderstorms form high above the desert floor with their base far off the ground, the falling rain frequently evaporates in the intense desert heat before it ever reaches the surface. Meteorologists call this virga. That process still generates the same violent downdraft and outflow winds that power a haboob, just without any of the rain actually landing to weigh down or dampen the loose soil first. In fact, drought conditions can make dust events worse rather than better, since parched ground leaves even more loose, unanchored soil sitting exposed and ready to be lifted the moment a strong enough gust front rolls through. And a dust storm this severe carries real health consequences beyond just poor visibility. Beyond the obvious respiratory irritation from breathing in that much airborne particulate matter, health researchers have flagged that strong desert winds can stir up and aerosolize fungal spores linked to valley fever, a genuine respiratory illness endemic to this exact part of the Southwest. In areas near old mining operations, blowing dust can also lift and redistribute legacy contamination, heavy metals like lead and arsenic left behind in abandoned tailings piles, spreading it across neighborhoods, fields, and water sources far from the original source. On top of the dust itself, Phoenix is currently also under a separate ozone high pollution advisory, meaning the combination of stagnant heat and existing air pollution is expected to push ozone concentrations up to levels that pose an independent health risk, particularly for children, older adults, and anyone with existing respiratory conditions. While the desert Southwest deals with extreme heat and rolling dust storms, a third hazard is quietly building across a wider swath of the West: extreme fire weather danger. Red flag warnings, the National Weather Service's specific alert for conditions where any fire that starts is likely to spread rapidly and become dangerous, are currently active across 5 separate states: Oregon, Utah, Colorado, Wyoming, and New Mexico. The ingredients behind those warnings are almost a textbook definition of fire danger. Humidity levels dropping into the single digits, meaning vegetation and dry fuels lose whatever moisture they had left almost immediately. Wind gusts running between 35 and 55 miles per hour, more than strong enough to turn a small spark into a rapidly spreading fire front within minutes. And this comes on top of California already managing an active, explosive wildfire, the Canyon Fire, that has already forced thousands of residents under evacuation orders. This is where the connection between all three hazards in this story becomes impossible to ignore. The same high-pressure ridge baking the desert southwest with record heat is also drying out vegetation across a much wider footprint of the west, stripping away the moisture that would otherwise make it harder for fires to ignite and spread. Extreme heat and extreme fire danger aren't two separate coincidental problems happening at the same time. They're two symptoms produced by exactly the same underlying weather pattern. There's an added layer of danger specific to this fire weather setup that's worth calling out directly: dry lightning. When those same high-based thunderstorms responsible for the hay-boob generating outflow, winds move over drier terrain without producing meaningful rainfall at the surface, they can still produce lightning strikes capable of igniting new fires, essentially delivering an ignition source without any of the rain that would normally help suppress it. That combination, dry fuels primed by weeks of heat and low humidity, plus a lightning source with no accompanying rainfall, is one of the classic ingredients fire. Behavior analysts watch for most closely because it can spark new fire starts across a wide area almost simultaneously, stretching already thin firefighting resources across multiple fronts at once. Step back and look at the geography here, and a clear pattern emerges. At the center sits a strong, nearly stationary ridge of high pressure over the desert southwest, compressing and heating the air directly beneath it and pushing temperatures toward all-time records in cities like Phoenix. Around the edges of that ridge, atmospheric moisture gets funneled in from the Gulf of California, fueling exactly the kind of powerful, collapsing monsoon thunderstorms capable of producing haboobs. And further out from the ridge's core, across a wider ring stretching from the Pacific Northwest through the Rockies and into the southern plains, the same overall pattern of sinking air, low humidity, and gusty winds is priming vegetation for rapid fire spread. This is the same basic principle we've seen driving extreme weather events all across the country this year. A large, slow-moving, or stationary pressure system doesn't just produce one type of extreme weather, it reshapes the entire atmospheric environment across an enormous footprint. And different regions within that footprint express the danger differently depending on their local geography, moisture availability, and vegetation. Phoenix gets record heat and dust. The surrounding Mountain West gets fire danger. And as this pattern shifts and evolves over the coming days, the specific hazard map changes, even as the underlying driver stays essentially the same. It's worth pausing here on something that gets lost in coverage of dramatic, visually striking weather events like hurricanes, tornadoes, and hayboobs. Heat is consistently one of the deadliest weather hazards in the United States, year after year, even though it almost never produces the kind of destroyed buildings or dramatic footage that makes for viral disaster coverage. Unlike a tornado or a flood, extreme heat doesn't leave behind visible wreckage. It doesn't knock down structures or wash away roads. It kills quietly through heat exhaustion, progressing to heat stroke, through cardiovascular strain on people whose hearts have to work harder to cool an overheating body, and disproportionately among people without reliable access to air conditioning. Outdoor workers, unhoused individuals, elderly residents living alone, and people in older housing stock that traps heat far more effectively than it releases it. A heat wave rarely makes for a dramatic news broadcast the way a collapsed highway or flooded neighborhood does, and that mismatch between visual drama and actual lethality is part of why heat consistently gets underestimated as a hazard, even by people who would never dream of ignoring a tornado warning. The lack of overnight relief in this particular event compounds that risk directly. When overnight low temperatures stay unusually high, homes and bodies never get a real chance to cool back down before the next day's heat begins building again. Medical researchers who study heat-related illness consistently point to that overnight recovery window as one of the single most important variables in whether a heat wave becomes genuinely dangerous or merely uncomfortable. Take that recovery window away, stack several consecutive days of it, and the cumulative physiological strain builds in a way that a single hot afternoon never would. Numbers on a forecast map are one thing. What this event actually looks like for the people living through it is another. And it's worth walking through because it explains why officials treat a stretch of triple-digit days as seriously as they do. For emergency medical crews across the affected region, heat waves like this one translate directly into a measurable spike in call volume. Ambulance services in past Southwest heat events have documented daily heat-related emergency calls climbing well above their normal baseline during sustained extreme heat stretches, cases ranging from heat cramps and heat exhaustion in otherwise healthy adults working outdoors, up through full heat stroke, a condition where the body's internal temperature regulation fails entirely and organ damage can begin within minutes without rapid cooling intervention. Construction crews, landscapers, delivery drivers, and anyone else whose job keeps them outside through the hottest parts of the afternoon carry a meaningfully elevated risk during a stretch like this, and many employers and local governments across the affected region have shifted outdoor work schedules earlier into the morning, specifically to avoid the worst of the midday and early afternoon peak. The dust storms carry their own distinct, immediate danger, separate from the health effects of breathing in particulate matter. Near zero visibility during an active haboob has been directly linked to serious vehicle accidents on desert highways and past events because a wall of dust can drop visibility from clear skies to essentially nothing within a matter of seconds, catching drivers who don't have time to safely pull over before it arrives. Transportation officials in the affected region routinely urge drivers caught in a haboob to pull as far off the roadway as possible, turn off their headlights so following vehicles don't mistake them for a car still moving on the road ahead, and simply wait the storm out rather than attempting to keep driving through zero visibility. And then there's the infrastructure strain that heat waves like this one place on the electrical grid, which becomes especially precarious, layered on top of storm-related outages. Air conditioning demand during extreme heat events pushes regional power grids close to their capacity limits. At the exact moment, thunderstorm outflow winds are simultaneously downing power lines and forcing utility crews to divide their attention between storm damage repair and managing a grid already under peak strain from air conditioning load. That combination, surging demand colliding with active storm damage, is part of why utility companies in this region have been increasingly transparent about outage numbers in real time during events like this one, since a full loss of air. Conditioning during a 118-degree heat event isn't just an inconvenience, it's a genuine health emergency for anyone inside that home, particularly elderly residents or anyone with a medical condition that makes heat regulation harder. If this all sounds familiar, that's because it should. This exact combination of a stubborn, record-setting heat dome sitting over the southwest, punctuated by dramatic monsoon-driven dust events and expanding fire danger across the interior west, has become a recurring late summer story across recent years, rather than a rare anomaly. Earlier this same summer, separate heat waves already pushed well over 100 million Americans under some form of heat alert on more than one occasion, with cities across the Midwest and West independently posting some of their hottest readings in years. What's notable about this particular event isn't that extreme southwest heat is happening at all. It's the specific combination of an outright temperature record in a major metro area, back-to-back top-tier dust storm events within the same month, and a simultaneous 5-state fire danger footprint, all converging within the same handful of days. As of the most current forecasts, the core of this extreme heat event is expected to persist through the desert southwest into the weekend, before beginning to ease somewhat in that specific region. But easing in one place doesn't mean the broader pattern is done. Forecasters are already tracking the same underlying ridge, shifting its influence with extreme heat, expected to expand into new territory over the coming days, including parts of Northwest California, Western Oregon, and Southwest Washington, an area that doesn't typically deal with this kind of sustained triple-digit heat. Cities along that Pacific Northwest corridor from areas near the California Oregon border up through Portland could see daytime highs pushing into the 100s, with overnight lows only dropping into the 60s to 70s, numbers that would be unremarkable in Phoenix, but represent genuinely dangerous, record-challenging territory for a region whose infrastructure and population are far less acclimated to that kind of sustained heat. Meanwhile, in Arizona, the active monsoon pattern responsible for this week's dust storms shows no sign of shutting off. Meteorologists are continuing to track additional rounds of scattered thunderstorms with the potential to generate more blowing dust and localized flooding, alongside continued elevated fire weather danger across the interior west as long as humidity stays low and winds stay gusty. The canyon fire in California remains an active, evolving situation, with evacuation orders still in place as crews continue working to establish containment. What ties this entire story together isn't really any single record temperature or any single dust storm. It's the fact that 3 distinct, genuinely dangerous weather hazards are currently unfolding simultaneously across a huge stretch of the western and central United States, all traced back to the same underlying atmospheric pattern. That's the story easy to miss if you're only following whichever piece of it happens to be trending in your own region on a given day. Someone in Phoenix dealing with a power outage from a haboob may have no idea that the same weather system is putting their relatives in Denver under a heat advisory, or that it's simultaneously creating the exact conditions a wildfire needs to explode in size 2 states away. That's increasingly the shape extreme weather takes in a warming climate. Not necessarily one isolated catastrophic event, but a single large-scale pattern capable of expressing itself as several different serious hazards at once, depending on the specific geography it happens to be sitting over on any given day. 60 million people under heat alerts is already a staggering number on its own. Layer a haboob and a 5-state fire danger zone directly on top of that same footprint, and you get a much clearer picture of just how interconnected, and how large in scale, a single stalled weather pattern can become. For anyone actually inside the affected zone right now, the practical guidance from emergency officials stays fairly consistent regardless of which specific hazard you're closest to. Limit outdoor activity to early morning or evening hours when temperatures are at their lowest. Check on elderly. Neighbors and relatives who may not have reliable air conditioning, since heat deaths disproportionately involve people isolated at home rather than caught outdoors. Never leave children or pets in a parked vehicle, even briefly, given how quickly interior temperatures climb under direct desert sun. If caught driving in a haboob, stop safely off the roadway rather than trying to push through. Near zero visibility. And in the areas under red flag fire warnings, avoid any outdoor activity that could create a spark. Parking a hot vehicle over dry grass, using power equipment, or having an open flame outdoors, since it takes very little under these conditions to turn a small mistake into a fast-moving wildfire. We'll keep tracking all 3 pieces of this story as they develop. Whether Phoenix's heat record gets challenged again before the pattern finally breaks, how far the extreme heat pushes into the Pacific Northwest over the coming days, and whether the fire danger across the interior West turns into new, fast-moving wildfires. If you want to stay ahead of whatever comes next, make sure you're subscribed, because with a pattern this large and this stubborn, this almost certainly isn't the last alert we'll be covering from it.